That was really the core idea, was to make the EVM execution a lot more performant and then build a consensus mechanism that could keep up with that really high execution throughput in order to maintain a really high degree of decentralization and full decentralized block production. I think Solana is processing somewhere between 2,000 and 3,000 transactions per second, whereas Monad is supporting over 10,000 transactions per second. And then also Solana is using relatively high hardware requirements. I believe the requirement is 256 gigs of RAM right now, whereas Monad requires nodes to have 32 gigs of RAM.
Welcome to Epicenter, the show which talks about the technologies, projects, and people driving decentralization and the blockchain revolution. I'm Brian Crane, and today I'm speaking with Keone, who is the co-founder and CEO at Monad Labs. Monad is one of the most ambitious and interesting new layer ones coming up, expected to launch next year. So I'm really excited to get into the details of that with Keone. Now, before we get into it, we just want to share a few things from our sponsors this week.
If you're looking to stake your crypto with confidence, look no further than Chorus One. More than 150,000 delegators, including institutions like BitGo, Pantera Capital, and Ledger, trust Chorus One with their assets. They support over 50 blockchains and are leaders in governance on networks like Cosmos, ensuring your stake is responsibly managed. Thanks to their advanced MEV research, you can also enjoy the highest staking rewards. You can stake directly from your preferred wallet, set up a white label node, restake your assets on EigenLayer or Symbiotic, or use their SDK for multi-chain staking in your app. Learn more at chorus.one and start staking today.
This episode is proudly brought to you by Gnosis, a collective dedicated to advancing a decentralized future. Gnosis leads innovation with Circles, Gnosis Pay, and Metri, reshaping open banking and money. With Hashi and Gnosis VPN, they're building a more resilient, privacy-focused internet. If you're looking for an L1 to launch your project, Gnosis Chain offers the same development environment as Ethereum with lower transaction fees. It's supported by over 200,000 validators, making Gnosis Chain a reliable and credibly neutral foundation for your applications. Gnosis DAO drives Gnosis governance, where every voice matters. Join the Gnosis community in the Gnosis DAO forum today. Deploy on the EVM-compatible Gnosis chain or secure the network with just one GNO and affordable hardware. Start your decentralization journey today at gnosis.io.
Cool. Well, thanks so much for coming on, Keone. It's really great to have you on.
Yeah, thank you for having me, Brian.
So I like to start by kind of asking people about how their crypto journey began. Like, how did you first become interested in crypto?
Yeah, so I'm 35. I've been working for like 13, 14 years at this point. The first 10 years of my career were spent in high frequency trading, working as a quant. So I traded in a number of traditional markets, mostly on the futures side. These are really high volume, like very liquid markets, like S&P 500 futures or 10-year Treasury note futures or crude oil futures, building performant trading systems that trade in these really efficient markets, generating very, very small statistical profits over a long period of time. And over some period of time, our team started to trade crypto, initially just sort of like without a lot of understanding about the underlying assets that we were trading. But crypto is really interesting from a trading perspective because there's so many different assets, like there's so many different coins themselves, but then a lot of different perpetual futures and deliverable futures and many different exchanges. So there's a lot of interesting correlation structure across the space. And that was initially what got me and my trading team at Jump Trading involved in crypto. But then at the same time, I was also just like getting really into crypto Twitter and enjoying all the narratives, all the memes, all the characters in 2020 and 2021. So that was sort of the introduction of the space. And then my team ended up merging into the crypto team at Jump Trading in mid 2021 and started working on Solana DeFi for a little bit of time. So then at that point, I was fully professionally in crypto prior to starting Monad at the beginning of 22.
Right. So you basically first started trading, just on centralized venues, and then also started doing more like on-chain stuff.
Yeah, we were from a trading perspective. Yeah, I was more focused on the centralized side. I mean, in a personal capacity, I was trying out different dexes and um, yeah, buying NFTs and yeah, getting rug done on coins. Yeah, on meme coins of 2020, 2021. Aside from Dogecoin, which did really well. But yeah, it was mostly in the professional capacity, more on the centralized side.
I'm curious, sort of from all your knowledge you had about, how markets work in the traditional markets work, and then when you kind of came to crypto, what were the things that, just seemed most weird to you or like most surprising?
I think two things that come to mind. The first is just the general inefficiency of the markets and the typical spreads that you end up paying as a retail trader. Like in the traditional markets, of course, depends on the liquidity of the asset, but for most normal futures or most normal equities, people will end up paying single digit basis points um, in spread and in slippage, like spread and slippage combined. Like their execution price is never more than like 1 or 2 cents different from whatever the midpoint of a market is. And this is for equity that's trading at $100 or $200 or more. So single digit basis points. And then if you go to the DeFi space, it's, the default is like a 30 bip fee. And then in addition, like when you trade, there's like some impact. And then when you price in like some slippage, and then you end up getting sandwiched attacked. It's just like it's very common for people to end up paying like 50 basis points or 1% or 2% in slippage. So it's just, like 2 orders of magnitude more than you would in the centralized space. So that's the first thing. And then the second thing is just the fact that when a transaction is submitted, it's in a pending state in most blockchains. Therefore, it's subject to the actual discretion of the block producer in terms of the ordering, which then has an effect on the execution price as well.
And then tell me, what's the origin story of Monad? Is that what you did after Jump?
Yeah. So I met James Hunsaker, who's co-founder and CTO here at Monad Labs in 2014 when we were both at Jump on the same trading team. And we've been working together ever since then. We both left Jump at the very beginning of 2022 and then started Monad shortly after that, along with the third co-founder.
And what was sort of the vision that, or like, the thing that caused you to say, okay, this is the thing I want to work on?
Yeah, I think with any startup, you really need an idea and an idea of also how that idea fits into um, the broader landscape of the space that you're working in and a clear problem that it's solving. For us, prior to starting Monad, when we were at Jump Trading for about 6 months, we were mostly working on Solana DeFi. And at that time in 2021, we could see that there were a lot of advantages to building on Solana because Solana was offering like 500 to 1,000 real TPS of throughput. So much, much more throughput than Ethereum. Ethereum was about 10 TPS, and also much more throughput than any of the rollups, which were, also in the like 10 to 30 TPS range. Much more throughput than other EVM layer ones, which were also in the like 10 to 100 TPS of throughput range. So there were a lot of advantages to Solana, but at the same time, builders who are building in Solana had to build with a completely different bytecode standard. They couldn't reuse any of the work that they'd done if they'd built for the EVM already. They couldn't use any of the really rich array of tooling and libraries and so on. And we just realized that we could give developers the best of both worlds and give them both performance and portability, focusing very heavily on optimizing all parts of the EVM stack. Um, and that was really the core idea, was to make the EVM execution a lot more performant and then build a consensus mechanism that could keep up with that really high execution throughput in order to maintain a really high degree of decentralization and full decentralized block production.
So I'm curious because I feel like this EVM discussion, has been a very long-standing discussion where, some people will be like, "Oh, EVM is fine," and then a lot of people will be like, "Oh, it's kind of like this, odd thing that was created early on, and just because it was the first, it has so much adoption." Do you feel like how do you feel like comparing the EVM with other VMs? Do you feel like using the EVM is the biggest advantage is just existing developer ecosystem tooling, contracts exist, or are there other kind of pros and cons versus other VMs?
Right. I think that so EVM is the just to state it very explicitly, EVM is the low level bytecode standard, but then typically developers are building in Solidity or occasionally in Viper or Huff or other front end languages, and that high level language gets compiled down to EVM. But it is really true that um, almost all capital on chain is in the EVM right now. Like over 90% of all TVL on chain is in EVM dApps. Additionally, there's a ton of existing libraries and tooling. Almost all the applied cryptography research is being done in the context of the EVM as well. Like people don't really think about that part, but very much on the research side, and a lot of zero knowledge research is being done. Ultimately to interface with the EVM bytecode standard as well. So it's really like for developers, um, they would probably prefer to build for the EVM, given all these network effects and the fact that by building for the EVM, they're not tied to like a one ecosystem or a very small subset of ecosystems. They can really deploy their work almost anywhere in the future. So it's really just future proofing the work that they've done, in addition to having access to all of the existing libraries and tooling.
Do you think this is something that like kind of network effect is gonna just continue compounding and grow bigger in the future? Or you feel other things like, Solana VM or like Move VM or any of these others have a real shot at some point taking over?
I think the future is very fluid. It really depends on the path of least resistance for developers. And our team thinks that the work that we're doing to make the EVM a lot more performant, so that then developers are really not forced to choose between performance and portability, will have an impact on how people think about like what VM to build for. You're right that in the current regime at this very moment, developers might be moving over to Solana because they feel that that's where they'll get the best performance, and also because there's a lot of excitement around the Solana ecosystem right now. But that all just can change with the introduction of new technology.
So when it comes to scaling, so removing all the bottlenecks and making sort of the EVM very performant, what are the things that you guys did to achieve that?
Yeah, there are at least four different major areas of optimization, or four different new architectures that have been introduced, in addition to just more generally um, optimizing. So, first of all, Monad is completely from scratch. So all parts of the stack are built from scratch for performance in C++ and Rust. And then we've introduced several new architectural improvements, which I can describe sort of briefly. I think the main way to think about it is that there's execution improvements, there's consensus improvements, and then there's improvements in how consensus and execution interact with each other. Um, so the first two improvements that I want to mention are both related to execution. The third one is related to consensus, and the fourth one is related to how consensus and execution interact. So on the execution side, the two major things that we've done are introducing a new database and introducing optimistic parallel execution. And the reason why these two things are both needed in order to make execution a lot more performant is because, well, first of all, to talk a little bit about the job of execution. So like in Ethereum, there's a block. It has a whole bunch of individual transactions that are supposed to be run sequentially in order to get to the end result. And initially, you might think that there's no way to parallel process because the true state of the world is the state of the world, assuming that all those transactions are run one after another. So, for example, if I start with 200 USDC in my account, and then the first transaction is me sending 150 USDC to you, and then the second transaction is me sending 100 USDC to my brother. So, the first transaction, when it gets executed, it'll take my balance from 200 to 50. And then the second transaction, when it runs, will take my balance from 50 to still 50 because that transaction will fail because it was trying to send 100, but I don't have 100 anymore. And so I think this is an example that shows you that you kind of do have to execute the transactions, at least in some sense, serially, because you need to have done that first transaction where I was sending you 150 before we can actually get the correct result of the second transaction. If we ran them in parallel, just totally naively, we would think that both of them succeeded. So there's a notion in which sequential execution is needed, but in Monad, we introduce optimistic parallel execution to do a bunch of work in parallel, but then do the right amount of bookkeeping so that we're keeping track of inputs and outputs, i.e., storage slots, both the values that were read in from a storage slot and then the values that are written to a storage slot. And although we do a bunch of work in parallel, we do bookkeeping and then commit those pending results in the original serial order and re-execute any unexpected results where the inputs have since changed. And so in that particular example, we do those two pieces in parallel. We would get pending results for both of those two transactions. And then the second pending result, we would then invalidate and re-execute because we would realize that it was done wrongly the first time.
Okay, because I think some other chains, they will like first try to check like, okay, what contracts does it touch? And then if it doesn't touch these contracts, then you say, okay, you can paralyze it. But in your case, you just execute it and then you see afterwards what it touches, and then you kind of like roll things back almost, or
Yeah, that's exactly right. Although I wouldn't call it rolling it back necessarily because nothing has really been committed yet.
right. Yeah.
But yeah, that's a good characterization though, that a lot of blockchains that do parallel execution require explicit dependency specification. So Solana is a good example of this, where when you submit a transaction, you have to say the exact pieces of state that that transaction is going to touch, and indicate which ones are going to be read and which ones are going to be written to, aka the read-write locks. And then that information is used as an input to the Solana scheduler to make decisions about how to parallelize work. And if you misspecify one of the dependencies, like if the transaction tries to go out of bounds and touch a piece of state that wasn't specified ahead of time, then it just automatically fails. So that's sort of a more um, explicitly defined model for transactions. And I think you would think that it might allow for more performance because you have all the dependencies up front. But in practice, what we found is that you can get a lot of performance from this pure optimistic approach where you just assume that everything is okay, that you're just reading dependencies on the fly, but then you put the results in a pending state and you commit them serially and re-execute if you need to.
maybe we can come back to this later, but one question I'm very curious about is the whole question of like MEV, PBS, because that I think maybe relates to this as well. But maybe let's go through the you mentioned 4 things, so let's go through the other ones first.
Oh yeah, sure. So I was telling you about I guess one of 2 major improvements that are improving execution. So I told you about the first one already, which is optimistic parallel execution. The second one related to execution is this new database that we've built called MonadDB. And so the thing to know about this particular topic is Ethereum stores all of its state in a Merkle tree. And the benefit of storing all the state in the Merkle tree is that the Merkle tree has a Merkle root, which is essentially a checksum over all of that state. And in that way, a commitment to all of that state. So, like, if you and I are both running full nodes and we both have the same Merkle root at the top of our tree, then we both know that literally every single piece of state is exactly the same on both of our machines. So we don't have to go like state by state and compare all of them. We can just compare the Merkle roots. It's a very efficient way of ensuring that we're on the same page. And the Merkle tree is, a successively hashed tree where every parent is a hash of all of its children. And then you just kind of like propagate that all the way up to the root of the tree. And the thing to know about existing systems is that this Merkle tree structure is generally embedded inside of another database. For Go Ethereum, it's LevelDB or PebbleDB. In Aragon and Reth, it's MDBX, which is another database. But in any event, like all of these Ethereum clients, they use a different database as the actual store for all this Merkle tree data. And it creates a lot of indirection because each of those databases themselves have another tree under the hood that's being used to define how state is or how data is being stored on disk. So when you want to navigate from the root all the way to one of the leaves in the Merkle tree, each time you visit a node, you're actually triggering another lookup into another tree. And so it's just really inefficient to like go navigate from the root of the Merkle tree down to any particular node because each node that you visit is going to trigger an entire lookup into another tree. So with MonadDB, apologies for the long explanation there, but for MonadDB, we're actually storing the Merkle tree natively on disk. So there's an exact mapping between how the tree is laid out, the Merkle tree is laid out, and the locations on disk, the pages. And then in addition to that, there's also a lot of other optimizations like introducing asynchronous IO support so that many pieces of state can be read at the same time, bypassing the kernel, a bunch of other optimizations. But what you really get is a much more efficient lookup system and also one that can support effectively parallel reads, which then interacts really well with the optimistic parallel execution because in optimistic parallel execution, you are running many transactions, each of which is at some point encountering S stores and S loads and triggering database lookups. And so while all these database lookups are being triggered in parallel by running all these transactions in parallel, the disk is also able to service a lot of those requests in parallel and start, serving state back to each of those transactions.
Okay, so basically what you're saying is like there's kind of this Ethereum has this like tree structure defined where the data, the state is hashed, and then you have a root hash, and then that's implemented on top of other tree structures which depend on the different databases. So you have sort of the tree on tree, which then makes it efficient, whereas you guys just have basically used the underlying tree structure of the database to just store everything. So you kind of get rid of one layer of complexity there.
Yeah, that's exactly right. And that's super important because all of this data is living on SSD. And the mental model that you should have about an SSD is that it supports a lot of work being done and a lot of lookups being done in parallel. So like a good SSD is a million or more IO operations per second. But the latency of each one of those lookups is somewhere between 40 and 100 microseconds. So you could think of it as like a bottle that has a really wide bottleneck, and you want to be able to stick a whole bunch of straws into the bottle at the same time, and like put all the straws in your mouth and suck a whole bunch of juice out of the jar all at the same time. But the straws are long, like there's a long amount of latency to look up any single piece of storage. So in the context of that nested tree structure that we were talking about, where you're going to end up having to go back and forth with the disk a whole bunch of times just to get one piece of state. And when you can reduce the number of back and forths substantially, you can get a lot more throughput out of the system.
And so that is primarily now an advantage also, because I can imagine there's different advantages to this, right? Like, so one is that when you execute a lot of transactions, you can just do it faster. Because maybe it also makes like running a node more efficient. If it's just like a normal node where you look up the state, that's not like a validator, or
Yeah, that's right. The database is just how all the state for any node, whether it's a full node or like a non-validating full node or a validating full node. Either way, they're still going to need to respond to RPC calls and execute transactions or go look up pieces of state. And all of those are accelerated by having a better state backend.
cool. So we have this optimistic parallel execution. You have the new database, and then what's the next one?
Right. So the two other areas that I mentioned are on the consensus side and on the interaction between consensus and execution. So to mention the consensus part first, we have a new consensus mechanism called MonadBFT, which is pipelined two-phase hot stuff. So hot stuff is a consensus mechanism that has linear communication complexity. That means that as the number of nodes in the network increases, the amount of overall number of messages that need to be sent increases linearly with the number of nodes, as opposed to other consensus mechanisms like Tendermint, aka Comet BFT, where it's quadratic. Like it's the square of the number of nodes in the network. Because in Tendermint it's all-to-all communication, whereas in hot stuff it's generally one to many, many to one communication.
Okay, so what's the kind of number of validators that you expect that Monad can scale to?
We expect a couple of hundred validators participating in consensus on day one of Monad mainnet. And then we have a slightly longer term roadmap to get that to the thousands. But with the current consensus mechanism implementation, it can support somewhere between 200 and 300 validators participating in consensus.
Okay, because that's kind of similar to, I mean, okay, Tendermint chains maybe is more, I would say, sort of up to 200, I think is probably the most that people run. What about their block time?
Right. So Monad BFT in Monad is being configured with a 1 second block time. As I said, 200 or more validators participating in consensus. And the other thing I forgot to mention is that Monad BFT has single slot finality, which we think is really important because um, it affects the bridging time. Like if you're trying to bridge off of Monad to another blockchain, then typically, the bridge really should wait until the chain is finalized before relaying a message to any other chain. And in Ethereum, where you have somewhere like 12 to 18-minute finality, that means it just takes a super long time to get your assets off of Ethereum to another blockchain. Single slot finality really helps a lot with faster bridging and faster settlement times.
What are your thoughts on the comparison of this versus the Solana consensus, which is, this proof of history, BFT-like consensus?
I think Solana has Tower BFT, which is not single slot finality. I think that some of the benefits right now of Tower BFT are support for a higher number of validators participating in consensus. I think they have somewhere between 2,000 and 3,000 validators right now, which is actually quite impressive. Like, I know that the meme on Twitter, or at least a couple of years ago, like people would always say that Solana is really centralized, and there are some aspects in which um, I would say that could be true. For example, the high RAM requirements of running a Solana node. But on the other hand, from a pure consensus perspective, it is impressive that Solana has 2,000 plus validators participating in consensus. Um, but that does come at a cost, and the cost is really finality is like not single slot. It takes some time. I think in practice they say like after 32 slots you can consider it to be finalized, but it's a little bit probabilistic even there as well. At 32 slots in Solana, 32 times 400 milliseconds is what is it, like 12.8 seconds.
Yeah, and I mean, one big difference with Solana, I guess that's not consensus related, no, but is that there's no Merkle proofs, no.
Yeah, that's another example where Solana removed the Merkleization, which I think has an impact on bridging, has an impact on the ability to run a light client. In Solana, they say that the light client is like a node that submits a transaction that creates a transaction that generates a proof, but it actually has to be included in the blockchain in order to generate like that proof. So it's not really a light client in the same way that um, when people typically talk about light clients.
And from the light client perspective, how do the light clients work for Monad?
So I think on day one we will not have a light client implemented, but it definitely could be implemented in the future with the consensus mechanism that exists. And um, yeah, there's no impediment per se because there is a Merkle root and there is like all the other things that you need.
Okay, cool. So that was consensus, and then let's go to the last one.
Monad implements something that we call asynchronous execution. And the way to understand that is sort of best understood by sort of just want to mention some numbers here. So Ethereum has 12-second block times, but the actual rough time budget for execution is only about 100 milliseconds, which is, if you do the math, like less than 1% of the block time. And so that's really interesting that the budget for execution is so small, like such a small fraction of the block time in Ethereum or in other blockchains. And the reason for this is the fact that execution and consensus are interleaved with each other. So typically in blockchains, what'll end up happening is the leader ends up choosing a list of transactions and then executing all of them, generating the Merkle root of the resultant state tree, and then sending that as a block proposal to everyone else. Then everyone
So
else
can you
receives
repeat
that.
that?
Oh,
Can you
sure.
repeat that? How they're interleaved?
Yeah. So in most blockchains, execution and consensus are interleaved. Execution is the single node problem of, given a list of transactions, what's the end state? And then consensus is a distributed systems problem of nodes talking to each other over a network. The nodes, if they're globally distributed, which they should be, then that means round the world communication, which can take hundreds of milliseconds. There might be multiple rounds of communication. So I think all in all, what you can see is that consensus ends up taking the vast majority of the block time, and execution ends up being squeezed into a very small fraction of that block time because of the interleavedness of execution and consensus.
Yeah, yeah. But for example, that's something where Solana is also much more, because of their system, there's much more execution, right?
Right. So with Solana, they're also exploring the idea of asynchronous execution. Tolly has written about this a couple times on Twitter, which has been really interesting for us to see. But yeah, Monad has been, uh, since day one, asynchronous execution has been a big part of the overall design. And asynchronous execution means decoupling those two problems of consensus and execution from each other. Asynchronous execution is the idea of moving execution out of the hot path of consensus into, I guess, what I would call a separate swim lane that is slightly lagging consensus. So what ends up happening is as soon as the nodes in the network come to consensus about an official ordering of transactions, then two things happen in parallel. One is they can start consensusing over the next block. And the other thing is they can all each independently execute that list of transactions that they've just agreed upon. And so when you move the execution out of the hot path of consensus into the separate swim lane, you can massively raise the budget of execution and use the full block time as opposed to only a small fraction of it.
So first the network agrees on just the order of all the transactions and how they're being executed, reaches consensus on that, and then the execution happens.
That's right. Yeah.
Okay, very interesting. So that also means, for example, if you're now a proposer, or like you don't really have like there's nothing really no discretion you can apply, I guess.
That's a good question. So, as a proposer, you still can apply discretion, and we think that in practice, the proposers definitely would apply discretion because that allows them to, um, more optimally choose the set of transactions that will end up paying fees. You were asking earlier about how MEV will end up working, and we do think that there'll probably be some sort of mechanism for network participants to submit ordering preferences to the block proposer in some way and attach a tip alongside that. So then that tip revenue is additional revenue for the proposers.
Because the proposers are the ones that come up with the ordering of transactions.
Correct. Yeah.
And then that gets consensus on, and then the execution part is that is basically predefined.
Correct. That's exactly right. So I think you said it better than I did the first time, which is when you think about a blockchain is really just a bunch of blocks that are in sequential order. And then in each block, a list of transactions, which are also in sequential order. So if you sort of like let the blocks themselves fade into the distance for a second, you just literally have like a long list of transactions that are all canonically ordered. And if everyone, or like Brian, if you and I are both running nodes and we both have exactly the same list of transactions starting from Genesis, then we should have the same exact state of the world because we're both applying the same transactions one by one by one by one by one, and each time making the exact same state transition and getting the same state of the world, the same Merkle root. So the ordering of the transactions purely determines the execution. It purely determines like what the correct state is. Yeah, basically like the only reason why we have Merkle roots is so that we can check each other's work and make sure that neither of our computers like got hit by cosmic rays and made a computational error. It's like just to make sure that we're doing the same thing.
Okay, so but it also means now if I'm the proposer, I get all these transactions, and now I can come up with a list, like an order of these transactions. So then there is potentially a lot of value, right, in changing this order, accepting different orders, putting in your own transactions, like all that kind of stuff.
Yeah, that's right. So, and this is really just true of any blockchain, but um, yeah, almost every blockchain is leader based. So there's a rotating leader, and then when it's your turn as the leader, you sort of have the privilege of being able to choose from various pending transactions that are in the mempool and assembling the next block, i.e., assembling the next ordering of the next set of transactions that get enshrined into the history of the blockchain. Of course, you need to choose valid transactions so that everyone else verifies them and accepts them and votes in your block. But you have discretion over what the ordering is. And what I'm saying is that that choice about the ordering is all determined during consensus. So you as the block proposer, you choose an ordering, you send it to everyone, everyone looks at it, checks that all the transactions are valid, does some other validity checks, which I can talk about in a second, and then votes yes. And then once, super majority of the network, like super majority stake weight has voted yes, now that list of transactions is now enshrined in the history of the blockchain. But that can be done actually before execution of that list of transactions happens. And so that's exactly what's happening in asynchronous execution is we're having the nodes all agree on the official ordering. And then once they've agreed upon it, then they can do two things in parallel, which are like start working on consensusing the next list of transactions, but then in parallel, go execute the things they all just agreed upon.
So I'm curious now, do you think that where this is going to is that we're also going to have a sort of proposer builder separation where as a proposer, I'm going to basically, plug into some builder or some other entity that, applies a lot of like intelligence to basically give me an order that sort of produces the highest value. Highest value for that builder then. And because that presumably there's a lot of value, right, in determining that order. Um, is that where you expect things to go?
Yeah, I think so. So the question of how the ordering is chosen is sort of orthogonal from all the other stuff that I mentioned. Um, like in the story I was telling you about how the proposer just chooses an ordering and then messages it to everyone. They all agree upon it. Now the order is enshrined, and now everyone can go execute in parallel to consensusing the next block. That entire story um, just kind of black boxed the decision of the proposer of how he or she chose that ordering. And to your point just now, like that decision could be made by outsourcing that decision to a third party network that is, like a proposer builder, like a PBS type thing in Ethereum, where there's a system for people to be able to submit bundles to the builders, have the builders build a block, have the block be submitted to a relay, which conducts a private auction from different builders to choose the ordering that offers the best overall amount of revenue before presenting some like the best option to the proposer and having the proposer choose that and enshrine it. All of that still kind of could work the same way. I don't know it's sort of out of protocol. So we'll see how it develops over time. But yeah, I think you could think of the ordering choice as being orthogonal to the other considerations of how consensus and execution end up working.
But like by default, when Monad launches, proposer and builder would be basically the same. And then, so it's not like enshrined proposer builder separation. And then someone may come and say, hey, we're going to create a modified client that separates out the proposer or plugs in some kind of builder mechanism.
That's right. Yeah. The default mechanism for block building is priority gas auction. So choosing the ordering of transactions based on descending gas bid.
I know, like, I think PBS is something that's fairly, controversial. I actually remember we did an interview with Vitalik at the EFCC, and we asked him the question, hey, how do do you feel it was the right decision? And he was like, I'm not really sure if this PBS separation was the right decision. Do you feel like, is this a desirable end state, this kind of separation? Or because in the end, right, there is potentially that a lot of value ends up kind of being extracted by, I mean, in Ethereum's case, right, we now have I think really just two builders who are completely dominant. Like, how do you want this ecosystem to evolve? Do you hope that there's going to be a lot of builders who compete, or you sort of say, like, don't really care, it's up to the market to figure this out? Or, like, how do you want to see this evolve?
Right. Yeah, it's definitely a complex topic. I think that, one thing that I hope we can accomplish through whatever the ultimate block building, whatever block building mechanism becomes sort of the dominant one. I hope that it involves a lot of builders. Ideally, it would be possible for the proposers themselves to just run the software themselves and build an optimal block. That way, it's much more decentralized in terms of that. The thing that you were mentioning, like ultimately the set of agents that are um, sequencing transactions, we want that number to be as high as possible. I think in terms of the value capture, in Ethereum right now, the proposers are capturing a lot of the value, because although there aren't that many entities that have high market share in the builder space, due to competitive forces, they do have to bid up to give up most of the value that is in that block to the proposer. So it is still very beneficial to the proposer network, which um, then is sort of revenue maximizing for the proposers, which is then good for all token holders because anyone can, has the ability to stake and thus, sort of get the returns of a proposer, or at least most of them. Um, there's also the part about how over time we're seeing more value get captured by applications through mechanisms where the builder needs to rebate some of the value to the application itself. And, then when the revenue flows back to the application, that can be good because either it makes the proposition of building an app more attractive, which I think, a lot of us in the space would agree is like a good thing to happen, because then it'll just encourage more ambitious apps to get built. Or potentially the revenue, although originally going back to the app, then could flow back to either LPs of that particular DeFi protocol, or maybe a rebate to the taker, to the end user. Um, so I think those are all different uh, things that can evolve over time. But yeah, I think to your original question, like we do, I think it is objectively better for there to be more actors that are ultimately choosing the ordering of transactions for the purposes of censorship resistance and decentralization.
Okay, cool, fantastic. So now I think we're coming to the fourth thing you mentioned.
Oh, actually, I think I've gone all the way out the plank because I've given the first two things were both execution related. Then the third one is consensus, and then the fourth was the separation between consensus and execution.
Oh, the asynchronous.
Yeah, yeah.
Okay, yeah. Okay, yeah. Optimistic parallel, new database, the consensus, and then asynchronous execution. Cool. So where do we end up with this? Like, what is the kind of throughput that is achievable here?
Yeah, I think the cool thing about these different technologies that we're introducing is that they all stack on top of each other. Um, so it's like, it's always exciting when you get a bunch of coupons in the mail, and then, one is like 50% off, one is 25% off, but they actually stack on top of each other because then you really have a magnifying effect. Um, so as I was mentioning before, asynchronous execution on its own is a massive unlock because, in existing interleaved systems, only a very small fraction of the block time can be used for execution, whereas by decoupling the two, uh, basically the full block time and expectation could be allocated to execution. So you can pack a lot more, um, literal, just like you can pack in the full block time as opposed to only a small fraction as execution time. And then if in addition to that, you have parallel execution, so we can do a lot more work in parallel. And then we can also have a more performant state database. We can respond much more efficiently to all these S loads and S store requests that are happening in parallel. Um, and we have a more performant consensus mechanism that can keep up with this entire system of execution that's fast. Then we can really, really see massive gains. The other analogy I want to mention is that in asynchronous execution, um, it reminds me a lot of the movie Limitless, where there's this, which is sort of based on the premise that you only use 10% of your brain. What if you could use 100% of your brain? Like, imagine how superpowered you would be. And of course, that's like a little bit misleading because I think that 10%, like the denominator, has a lot of gray matter, like supportive tissue or something in there. But it's not really true that you can go from 10% to 100%. But it's a nice fantasy to think about. And in this movie, there's this guy who takes a pill that allows him to go to use 100% of his brain. And he's just immediately super powered. And he's doing awesome. And then, of course, there's like a narrative arc where, by being so powerful, he gets in a lot of trouble and then he's able to somehow work out of it. So asynchronous execution is like that, where you're going from using only a small portion of the block time to using the full block time. And then when you stack this on top of these other improvements, we can really get significant throughput. So now back to the question you were actually asking. So Monad is supporting over 10K TPS, replaying existing Ethereum history. So this is not 10,000 transfers or 10,000 ERC20 transfers. This is 10,000 real transactions from the distribution of recent Ethereum blocks per second, which ends up being about 1 billion transactions per day, or about 1 billion gas per second, which actually is kind of funny. Like now on Twitter, a lot of people talking about this goal of giga gas throughput, or 1 billion gas per second, which is the throughput that we're able to achieve on Monad by stacking these different technology improvements while running on reasonable hardware requirements, which I think is another thing to point out, because a lot of the goals of getting to giga gas throughput are assuming that you're running a centralized L2 where there's one server, and that one server has like a massive amount of RAM, and is like kind of a supercomputer. That doesn't really work with the principles of decentralization. Like, we want to have a fully decentralized network where the nodes are literally globally distributed with the full overhead of consensus. We want anyone to be able to run a node. Like, it shouldn't be expensive to run one of these nodes. So if you can get to a giga gas of throughput, but you have to have a massive, like, a terabyte of RAM or more. Like, people are talking about having like machines that have 10 terabytes of RAM. It's just like crazy, crazy machines in order to get that throughput. But with Monad, we're getting that throughput while using commodity hardware, like a server that costs $1,000 a year to run.
Okay. And then can you just contrast this with Solana today? How does it compare?
I think Solana is processing somewhere between 2,000 and 3,000 transactions per second of real non-voting transactions. And whereas Monad is supporting over 10,000 transactions per second. So it's like, 3 to 5x the throughput right now. And then also Solana is using relatively high hardware requirements. I believe the requirement is 256 gigs of RAM right now, whereas Monad requires nodes to have 32 gigs of RAM.
How do you imagine this is going to evolve in the future? Do you think you can scale that a lot more, or is this are you hitting the limits here with these improvements?
I think there's the capacity for another like 2 to 5x of throughput improvements. The real constraint is on the networking side. So Monad wants nodes to have 100 megabit bandwidth, and the throughput is up to a certain point is sort of linear on the consensus side with the amount of bandwidth that's allocated. Um, so, but it's like not, we don't think it's reasonable for a decentralized network to require gigabit bandwidth, for example. Like there's just sort of like a physical limitation to the overall throughput that's imposed by the networking.
Okay. So basically, bandwidth becomes like the main bottleneck, and then that's something where, okay, if you go up with bandwidth requirements, it just means that you have to start compromising decentralization to some extent, or to another extent, it just becomes harder to run around this. I mean, I think in Solana's case, right, that is a real challenge. I mean, we've had various times in the past, data centers would basically say, hey, it's getting DDoS because it's getting so much traffic. So I think finding like data centers that support like Solana validators is not so easy.
Right. Yeah, I think that. Well, I think the most important thing to focus on is like the fact that there is like for Solana or Monad, there is a commitment to having a fully geographically decentralized validator set, having hundreds or thousands of nodes participating in consensus. Like a lot of the more recent narrative has been around like just like very, very centralized setups where there's a single sequencer. Um, like if in that situation there's no consensus at all, and so if there's no consensus, then that whole thing about the bandwidth like doesn't become a consideration because the node doesn't have to talk to anyone else. Like it literally is just the one super node that all the requests are flowing to, and all of the RPC calls are going to, or maybe going to like a slave or something, but something in the same data center. So I think that's the single biggest thing, and that is ultimately what the constraint will be is the networking limitations to support a fully geographically distributed decentralized network. But I think it is very important. And then I think from that point onward, then Monad would perhaps pursue a horizontal scaling strategy where there's several instances of Monad that each are very computationally dense, like each delivering over 10K TPS of throughput. And then, when that 10K gets saturated by whatever set of apps that are there, then maybe there's like another Monad instance that's also highly decentralized, has nodes all around the world, that has a more specific, like different, different focus as well.
Right. That becomes sort of a sharding like design. But I mean, fortunately, 10K TPS is quite a bit, right? So it should probably has some time.
Yeah, you want to shard when you've reached the limits of what the hardware can really support. Like I think that it doesn't make sense to shard. Like if each network could only support 100 TPS, and then you need to have 100 shards in order to get to 10K TPS, that's not very good. But if one shard itself is 10K TPS, and then you set up 100 to get to a million TPS, that seems much more justifiable to me.
Yeah. And I mean, it sounds like previously you were sort of referring a bit to like Mega Eve, right? Which is the other project that's trying to super scale EVM, but doing it with this kind of supercomputer centralized approach. And to me, it seems very obvious that's like a massive compromise, right, on in the end what we're trying to do here, right? We're having like decentralized networks. But yeah, I mean, I guess do you think, but let's say Mega Eve will, at the expense of decentralization, then probably be able to process even much more than Monad, or like, what are your thoughts on like Mega Eve as a comparison?
Yeah, I think there's a number of different projects that are trying to build like high performance L2s, um, taking advantage of the fact that there's no consensus overhead, and you can run that one node on a really big box. I think another example is Rise L2 is also doing this. I think Radio is also doing this. I mean, you could argue the Hyperliquid itself is also kind of doing this, because the nodes are all in Tokyo. Like the node, in order to run a node, you kind of have to have it in this one geography, high RAM requirements on the nodes. So yeah, I think there's a number of different projects that are all trying to trade decentralization for performance. And I mean, if you think about it, like, just your expectation should be that there could be more performance if you cut out all of the decentralization aspects and all of the overhead of consensus and so on. I think Mert actually has a pretty funny take on this, where he talks about how L2s really should be like a lot higher TPS than Solana, because they're all running single centralized sequencers and you can add all of their throughputs together. So the fact that like right now Solana has higher throughput than all the L2s combined, when the L2s like have this massive advantage of centralization, is actually pretty crazy. So yeah, I think that they're different designs. Like there's definitely some trade-offs being made, but the goal of Monad is to offer really high performance while having a very high degree of decentralization as well at the layer one level, and we think that that's quite important. Um, that's why we're all here, is to help build new technology that helps decentralization to have a greater impact and decentralized apps to have a greater impact.
So I'm curious about the developer experience here. Is it basically just going to be, hey, I'm developing just like for Ethereum and it's pretty much the same, but the difference is just faster block times, more throughput, cheaper transactions? Or are there differences when it comes to developer experience as well?
On day one of mainnet, the focus is really just pure EVM equivalence, so that you could take any application built for Ethereum and redeploy it on Monad without any changes. You don't even need to recompile it. Um, we are thinking about some additional quality of life improvements for developers. Those are things like raising the bytecode size limit from 24 kilobytes to 48, or maybe even more than that. It's things like adding support for new precompiles. For example, there's a number of different cryptographic functions that frequently come up that currently have to get implemented in Solidity and are very expensive to do so. But if there's a native implementation, then that should just kind of be baked into the node code, and you should just be able to call it with a precompile. So we're working on some of those, and they will either be included in Monad mainnet, or if not, right at mainnet, then at some point a little bit later on. We're also looking at the account abstraction space quite a bit, and thinking about, well, first of all, following along with the existing EIPs that are contemplating different ways to ultimately get to native account abstraction. I think EIP 7702 is getting a lot of traction. So this is the EIP that would sort of allow any EOA to effectively become a smart contract account as well, by having a pointer in its code slot to point to another smart contract, like another address where code lives. So we're looking into that. And again, it'll either be included in mainnet or probably sometime shortly thereafter. But yeah, at the end of the day, from a developer experience, developers can expect um, a fully EVM equivalent experience so that they don't have to change anything. But in addition, our team is evaluating ways to make life easier for developers. So it's actually easier to develop on Monad rather than on Ethereum.
Cool. I'm curious on like a very different topic. There's a lot of competition around L1s and, building community and sort of getting mindshare is not easy. I think you guys have done a fantastic job there, and it feels like there's already a lot of like interest in Monad, people building on Monad. What have you guys done in that front that has had the biggest impact?
Yeah, I think everything is very synergistic in the sense that I think there's a lot of people in the crypto space that are really passionate about um, the ideals of the space and excited about seeing the success of new decentralized apps and excited about trying new things and giving feedback. And also that frankly, like spend a lot of time on crypto Twitter every day and follow along with a lot of the storylines. I think what our team has done well is just creating a welcoming home for many people that share these common interests, and especially during the bear market of 2022, 2023, just having creating this welcoming environment where everyone was kind of a little bit down in the dumps from all of the negative news and sentiment and so on around crypto, but still very passionate. And a lot of people sort of ended up joining the Monad community and making a ton of friends and contributing in different ways, which then um, really has a flywheel effect of now we're at the point where um, artists that are creating new art involving the Mon animals, which were created by members of the community, or like just leaning into all the memes and jokes and fun, then have a massive audience for their art, which then is very just encouraging to them and gives them more of a reason to create more art, which then creates more enjoyable experiences for everyone else, which then it's very, very positive sum. And then, lastly, also very positive for builders who are building on Monad, because then they immediately get some moral support from people who are cheering for them to be successful and trying out the beta versions of their products and giving feedback and becoming community members. And yeah, I just think that there's, it's really just about the fact that for various reasons, the community is attracted. A lot of people are very long-term oriented and care a lot about the space and have enjoyed making friends and then getting to go to meetups around the world to meet up with their friends that they've been hanging out with a lot in person in real life. One last anecdote that I'll mention is so around DevCon, we hosted the Monad Madness pitch competition. This is the second iteration of something that we're hoping will become like very much a fixture of what we do. But it was a competition for 25 teams to present in front of a panel of really leading investors in the space. We had people from Paradigm, Electric Capital, Pantera, Animoca, IOSG, and then anyway, the point those were the judges, and then a bunch of other investors were in attendance in the audience. But we had anyway, so there was like these teams got to go on a giant stage, pitch their project, compete for $500,000 worth of prizes, get the attention of judges so that they could attract money in their next fundraise, and then also got over 400 people to attend in person, 1,000 people attending on the live stream. And then kind of around this, we had over 150 people fly from other countries, mostly in the Asia area, but we had people traveling from as far away as Greece and Turkey and so on, all the way flying to Thailand just to go attend the community meetup. and spend the week like hanging out with their friends that they've met online. So yeah, I think in short, there's just an incredible amount of energy and excitement in the Monad community. And then that has translated into benefits for builders as well, which then makes the ecosystem stronger, which then pulls more people in and hopefully pulls a lot of people in that have never known anything about crypto in the past as well.
The maybe final question. So what are the timelines here? Like when do you expect mainnet to launch?
We're expecting mainnet to launch sometime early next year. No exact date at the very moment, but the team is working really hard on this. And I think in particular, we're expecting to launch the test net imminently in 2025.
Cool. Well, thank you so much, Keone. That was really great. I really enjoyed getting into the details here, and I feel like this is a lot of like very smart and interesting and reasonable decisions that you guys have made that I think can end up in a really powerful blockchain. So thank you so much for coming on. It was a great pleasure.
Yeah, thank you for having me, Brian. It's really nice chatting with you.